Hi guys, this lesson is going to go a lot faster than the last one. This one is simply called fade. This time, instead of just pulsing the output on and off, we're going to play with the brightness of the LED so that you can have dim ones and bright ones, whatever you want to do with them. And we do that with pulse width modulation. So let's get started. Get back up here to the top of the page, and you get a quick little paragraph on what pulse width modulation is. Basically, what it's saying is it's a technique used to control the brightness of an LED, the speed of a DC motor, or the control of a servo motor, or where you have to get an analog output with digital means. In other words, we want a full device and make it think it's seeing an analog signal. So let's study a little bit briefly here. We're not going to go into great detail. I just want to show you one chart. This, of course, along the bottom is time, and up the left-hand edge is voltage. So with digital, the voltage is either off or on. Off or on, right? That's the only two states we're allowed. But we can play with how long we leave it on, and that's called its duty cycle. So the amount of time that it's on and the amount of time it's off is called a period. And we measure the duty cycle within that period as to how long it's turned on. So here you see it's 20%. That means that we turn the output on and we hold it on for 20% of the total period, or the other 80% is turned off. And we turn it on again, hold it for 20%, drop it off, hold it for 80%. See how that works? So 40% duty cycle, what's that? That's just twice as long as the first illustration. 80% duty cycle, and of course 100% duty cycle means we never bother to turn it off. We simply turn it on and leave it on. Okay, so that's what we're going to be doing. We're going to be playing with this duty cycle and changing the width of that pulse. And by doing that, we fool the human eye into seeing the brightness, because the LED doesn't get to come on the full brightness. And down here we have the simple circuit. Let me blow it up. This looks a lot like the blink circuit. In fact, it's identical with one exception. The blink circuit, this green wire, is over here on LED 13, which is strictly a digital pin. So we could only turn it on or turn it off. But we moved that green wire over here to pin 6, which also has this little tittle next to it. That means this is an analog pin. So we can vary and play with that output on that pin. Just take a second here and look. You see 3, 5, 6, 9, 10, and 11. Those are all analog pins that we can play with. And in the upcoming videos, I will be using those to do another demonstration. Right now, we're on pin 6 through the LED, through the 220 ohm resistor, and back to ground. That on the breadboard looks like this. Okay, here's pin 6 coming over to the breadboard, through the resistor, through the LED, and back to ground. Okay, so it's a simple circuit, easy to set up. The code for that is very simple. This little illustration is very simple. Let me close this down and get rid of some of the brightness for you guys. Make that a little easier to read. This sketch is real simple. Here we said we want to use an integer, and we're going to name it LED pin, and it's going to represent pin number 6. So we go into the setup mode, right? And everything between these braces gets performed, but there's only one thing to do. we use the function called pin mode, and we say pin 6, LED pin. We want to use it as an output, and that sets us up to go. So we go down into our loop, which is the repeatable code that goes over and over again, right? And we set up our fade circuit, and we use the infamous for loop. We've delved into this quite a bit in the last video, so I'm not going to go too deep with it. Remember, I is set to 0. That's our iteration. This is where we test it. If I is less than 255, then we do everything between this brace and this brace. Okay, and what is it we're going to do? We're going to do an analog write. So we're going to output to the pin. Which pin? LED pin, which is pin 6, the value of I. Okay, so we're going to write, at first it's going to be 0, right? So basically the LED is going to be turned off. And then it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up until it hits 255. And then it stops this loop. But each time it sets that pin, we delay for 5 milliseconds to let it settle in and let the eyeball see something happen. Because if we didn't do any delay in here, this would happen so fast that the eyeball wouldn't be able to detect much of a change. So we delay it a little bit. So once that for loop is satisfied, we'll have the LED completely turned on. So now we want to fade it back to nothing. So we reverse our test. So we go into another for loop. This time we say I is equal to 255. And we say, as long as I is greater than 0, drop into the loop and do this. So this time we're going to write to pin 6, right, the value of I. So the first time it's going to be 255, or fully bright, 254, 253, 252. You get the idea. And again, we're going to delay between each iteration of the for loop by 5 milliseconds. Again, this is to give the eyeball time to see the brightness of the LED begin to fade. Now, one thing I didn't point out in these for loops, if you notice here, I have I minus minus, and here I have I plus plus. Okay, I plus plus means add 1 to the current value of I. I minus minus means subtract 1 from the value of I. That's the difference between those two loops. So you can see we're counting down here by subtracting. So if we load this code into the chip, it ought to run, it ought to work just fine. Here's a recording that I have where I test it out. Let's see how it works. I'll skip it ahead a little bit. There we go. Flip it over on the edge. It makes it easier to see. So you can see the glow of that LED is changing as we change the value of I. Now, when you're playing with pulse width modulation on these Arduinos, the only legal values is something between 0 and 255. That's the legal range you can use, and that's why we use these numbers in our little test program here. Now, I'm going to leave that up, and I'll bring up the live camera. Whoops, got the wrong one there, guys. There it is. Alright, this is the live camera. And again, let me set it up on its edge. You can see it fading in and out. Now what I'm going to do is I'm going to go back into my code here, and I'm going to change my delay time from 5 milliseconds to 15 milliseconds. And I'm going to upload that change to the chip. And now watch the rate at which this changes. Look how much slower it is. I'll play this one over here just so you can see a comparison. Look how much slower I have it now blinking on the live camera. Right? So we can adjust that fade rate is, with the delay time. I hope this makes your first introduction to pulse width modulation simple, straightforward, and something you feel like you can use. All right, we'll close it down and get ready for the next video. Thank you.